All right, welcome back to my series where I take on the challenges in my book, The C Sharp Player's Guide. Today we're doing this Maelstroms challenge. This builds on this base game up here, the Fountain of Objects, and we've already done these two other expansions, and now we're going to do this expansion. The book doesn't demand that you do every single one of these expansions. You either do the base game and two expansions, or you start with my code for the base game and do 5 of these 6 expansions. But so today, this is the one we're doing, Maelstroms. So we're adding in a new type of hazard. This one doesn't just kill you, but there is a side effect of running into one of these. It will sweep you away to another room, and there are rules down below that describe how that happens. But you can hear these maelstroms from adjacent rooms, and the difference between this and like a pit is that these things can actually move around, and the only time they actually do move around is if you bump into one. So if you do run into one, then it causes you to like teleport. Well, this says moves 1 space north and 2 spaces east. The maelstrom moves 1 space south and 2 spaces west, and then it wants you to handle the scenario where the you or the maelstrom would end up off the map. Some way, somehow, this gives some options: clamping it to the map, wrapping around to the other side, or any other strategy. I will probably do this wraparound. Yeah. So the first thing to do the first thing to note is this is a thing that's actually more like the player, in the sense that this is not always like this can be in the fountain room or the entrance room. This like or it can be in any other room. So in that sense, it's a lot more like a player than it is like a room. And that's something to keep in mind as we figure out how we're going to approach this. So I think the next step is probably to come over here and well, we'll do two things. One is we'll place our maelstroms in the map somewhere somehow. And this says we place let's does this it doesn't say, it doesn't declare where that must be. So we get to pick where it is, and it says so we have 1 for the small, 1 for the medium, and 2 in the large size room. So I don't know. Maybe we can put the maelstrom right here. Let's say I'm picking a random spot. There isn't a specific reason, and I don't know. Let's just pick this red color to represent a maelstrom, and then we can save it. I'll just save it here. So again, I'm doing this is just so that I can remember where things were as I make my decisions, that I would normally sketch this out on paper instead. And let's see. I'm going to put the maelstrom here. Let's put it down here. And then in this one, we had to put 2 in. So let's put this here. And let's put 1. I don't know. Let's put it here. These are arbitrary. There's no rhyme or reason to why I'm doing what I'm doing. Of course, if you didn't do the small, medium, large challenge, you would only have to worry about this small version. But all right, there we go. So let's talk about how we would fit this into our design, and we can revisit these cards here. I think that makes sense. Again, this is because the maelstrom moves around, and it can be in any of these other rooms. I don't think this one makes sense as a room. I think it makes more sense, honestly, as like the player. And in fact, it's like in a lot of ways, it's almost exactly like the player. Like it's like this other like thing that lives and moves around in the map. So I actually wonder if this isn't maybe knows where Maelstrom is at. Yeah, I don't like I wonder about making like a character. Like what if we had a base class here that was like a character class. So this just represents something that can move around within within the world. We just add another one. The player is a type of character. The Maelstrom is a type of character as well. That could be pretty easy to do. Something's got to like resolve that like interaction between the two. This thing here, like this already has this resolve player action. So maybe we can keep the logic there. Like maybe that's covered there. That if the the Maelstrom and the player end up in the same place. I could see a bunch of other ways that we could handle this. Like this like interaction is kind of it's almost like an aspect of the Maelstrom itself. And one thing we could do is we could give any non-player character that's in the same room as the player a chance to interact with the player. Something like that. So like we could shift that responsibility to do handle that specific interaction with the player here. Um, I don't think that would be a bad design, honestly. We only have the one. Though if we're going to do that, then perhaps we'd want something similar for allowing whatever room they're in to interact with the player and any other creature, any other thing to interact with the player as well. So maybe that would be that creates this like abstraction, this notion of the game doesn't know or care what the room is or any other character that's in the room. But for the room that you're in and for any character that's in the same room as the player, we're going to give them a chance to interact with the player. Now, like that's a design that could work up until we want something to be able to interact with a player from an adjacent room or something like that. So, and then in that case, like the player isn't going to interact with the player, so we'd almost need like that almost becomes like a more complicated inheritance hierarchy where you have the player and you have a oops. I guess I'm just thinking through how this could work. Like a non-player character that is derived from character and it can interact with the player. So this is abstract. This is also, I'm just going to put an A. This is also abstract. This thing's not. So now we built this sort of like extension point where any we got to give this his actual interaction. Like I said, there's a lot of ways we could do this, and we could have just put this in the Fountain of Objects game and just handled it that way. So maybe we'll still do that. That's fewer cards, fewer classes, simpler design. But teleports the player on encounter. So if we encounter it, then that's the response. That's what's going to happen. Yeah. So, but again, like I said, it leaves open this option of, hey, we could have literally any type of non-player character that could interact with the player in all sorts of ways. So I do like the flexibility that gives us, even though there is more complexity here. So when we get to the code, we'll probably play around with this both a little bit. But I think that's kind of the general pattern that we're going to go in. This also now is going to have, like, it needs to know about all of the Maelstroms in the game, but maybe what it really needs is like non-player characters. So maybe it just needs to know about all non-player characters. So I did actually color these rooms red. In theory, this could like perhaps we could an alternative way to think about this is actually the room is still just a plain old room, and there happens to be a maelstrom in here, and we can make this white again, and there happens to be a maelstrom in that room, and there happens to be a maelstrom in that room, and there happens to be a maelstrom in that room. So this way of visualizing it helps sort of illustrate that this isn't a room, it's just a thing that happens to be in the room. So I like that a little better. Anyway, I think at this point we could probably go start to play around with code. Like, so we kind of explored some ideas, and I don't know that I'm totally set on any of them. But let's just move forward with kind of what we've got here, and we'll see if we end up keeping it. I'm going to move this out of the way and then jump over here to code. So where is that player class? I'm going to hit Control T, which is like go to literally anything, and I'll just type in player. This is usually how I get around in the code. I don't have memorized where all the files are and all the things that are in it. I just hit Control T and just go to the thing that I'm looking for. Like, it doesn't have to be an exact match. You can see that, like right here, it's showing this player input, and if I just search for, say, input, like, it's able to find it. I don't have to. Like, even this, I get smart enough to say, oh, there is two things here that, and like, it's not even just finding just types. Like, here's a method, but it's finding this thing that has a P, and then later on it has an I like that, but it also finds this where there's a P and an I back to back. So anyway, it's a pretty nice little tool, that Control T. But so I just want to go to player, and here it is. So we could public class character. This is we said this is abstract, and we're gonna push down into this. We're gonna push this code, and then we're gonna make this derived from character. So now this doesn't have any meat to it anymore. And then the card design that we had, we actually said public abstract. We're gonna have a non-player character, which is a character. It doesn't add anything else, but then we're going to have a public class Maelstrom. And again, this doesn't need anything. And I said this earlier in one of the other challenges. If you have these classes that have nothing in it, that could be a sign that it's definitely a sign that there's a different design that doesn't require creating all these new types. And maybe the way that could work is we could just have a character class, like in this case, where every derived thing adds no additional logic so far. Maybe we could just have a character class and then have an enumeration that is player, Maelstrom, and any other type that we feel like we want to add into this. So that would be another way we could do this without this. So that would not create, 4 different classes. We'd have one class and an enumeration that tells us the type. And I think that can work as long as as long as each of these like specialized types don't have their own data or their own logic. And I think our expectation is that we, in fact, will have some logic, but let's just keep going here. So every single one of these has a location, and we need to put these into the game now. So let's see. I'm looking back. I think I can get. Well, I'll keep this over here. For the small game. So I guess here's the trick. Is this isn't a room, so we can't use map.setRoom. But somehow this thing has to know about all of these non-player characters. And we like this thing like arguably could just say, so maybe what we need is some sort of like, and we know there could be multiple of these. So maybe this is a private, maybe this is an array of non-player characters. Even as I see that written out, I wonder, like, non-player character is a very RPG type thing to say. I kind of want to just call it monster, though. Still the same thing, it's just a different name. And you can, whatever it's worth, you can do that. Uh, so I'll make that read only. And then, like I said, in here, I could say monsters equals new monster array and just put like new Maelstrom. But somehow these have to like this thing doesn't actually know this doesn't have the responsibility of knowing how to set up the world. We put that in a different class. So for this guy to be making this kind of decision feels like it's maybe misplaced. And like he doesn't know if he's got a small, medium, or large map. So he doesn't even know what blueprint he should be following. So we could and we could pass that information in, or maybe we can infer it from the size of the map. But I think it'd be better if, just like how we passed in the map and the start location, I think it might be better if we pass in, like, what if we pass in an array of monsters, and then down here we just say that off. I actually usually like having these in the same order as their parameters, and also as they appear here. So I'm going to do just a little bit of reordering. Map player monsters, map player monsters, map. Mm-hmm. It's not the player, but it is for the player. All right, so now we have this array of monsters. And now we just need to come here and we need to pass in some monsters. So I'm going to do monsters equals new monster. So this is the large game. And there were 2 Maelstroms in here. New Maelstrom. And this was at, let's see, row 0, 1, 0, 1, 2, 3. Column 0, 1, 2, 3, 4, 5, 6. And then another one that is at 4 and 0, 1, 2. Okay. So we just set up these monsters in a little array and just pass them in. So this guy is told what monsters are going to be in the game. He doesn't come up with them. This class here, the game factory, he's the one who makes those decisions about what a game, a round of this game would look like. And then we just need to do a similar thing here. I don't like how it did that indentation. That was surprising and weird. So this one, there's only one, and it's at 0, 1, 2, 3, 4, column 1. And this one we put at 0, 1, 2, 3, and 3 and 2. And again, like if we had randomness, we could randomize these. Okay, so the game has monsters in the form of Maelstroms, and they've been placed in the world. So we haven't handled sensing, and we also haven't handled their interaction if you run into one. So let's come down here to our sensing code, which is getting honestly more and more awkward. But we could just do this, and honestly, like it's very similar code to this. And that makes you wonder, is there a way that we can just, well, actually, I was gonna say it's really similar to this, but it actually has nothing to do with the rooms. It's actually totally different. I take it back. It's nothing like that. Simply because of how we've done it, that we've treated it as this. It isn't a room that moves around. It's something that's like on, So basically, kind of like, and I think I kind of illustrated that fairly well here. That like there's the grid that's like these like immovable rooms, the structure of the building itself, and then there's these things on top of it that they can move around, and so we access those through a totally different mechanism, and we do that by saying for each monster in monsters, if monster is Maelstrom, so okay, I'm kind of winging this as I go. Let me explain. So what we're going to do is we're going to assume that there's no Maelstroms nearby. And then we're going to go through all of the monsters that we do have, and if that monster is a Maelstrom, and that's the only type of monster we have. So we could just simplify this a lot right now and just say, like we could have just had, we could have, we made this whole inheritance hierarchy. Player is derived from character, but Maelstrom is derived from monster, which is derived from character. And we could have, for example, just had a player that's its own thing, and then we could have just had a Maelstrom class that also just had location, and just like collapse all three of these. So detangle this from the rest of this, and then just collapse all this down into just a Maelstrom class. That would have been simpler code, because then like in this case where we're at right now, every single thing in this list is we know as a Maelstrom, so we don't even have to check. But alas, yeah, like I said, I do like the flexibility this will give us. It'll make, I think, the next challenge a lot easier. The Amarok challenge will be a lot easier because of this. And like I said, I like the flexibility that it gives us. So it's probably over designed for what we're going to accomplish in this challenge, but I do like it. So if the monster's a Maelstrom and monster dot location. So okay, somehow we got to figure out if these are if the player's location So we got if the player's location and the monster's location is within 1 square of each other. And I feel like we could do that here. Location dot x minus player dot location dot x. We could put that in here, but I feel like this deserves to be a method, and I think that if we're going to make a method for it, the best place for this, because this is a question of are two locations adjacent to each other. I think what I want to do is come into this record and add in a method public bool is adjacent to another location. So we'll just add a method in here that answers this question of is this location adjacent to another. And in this case, we're going to define adjacent as basically within one row and also within one column. And let me come back over to here to kind of like, let's analyze this. Like it basically, so this is like row, like, well, yeah, let's compare it. So these two, the difference, like this is row 1 and this is row 2. Their difference in rows is 1 or 0. Yeah, so if we take, well, here, let me do this. I'll make a little, we'll color this guy something else. But this is the player. Sure, why not orange? I'll take that. All right, so if we got this guy here, the player here, and then the maelstrom here, if we subtract this guy's row from this guy's row, and we're within 1, so if that comes out to be either -1, which this minus this, so this row is 0, 1, 2, 3, 2, and 3. 2 minus 3 is -1. Then we're within 1, and if we flip it around more like this, then it'll be +1, or if he's here, it'll be 0. I don't know if I'm making a lot of sense. If the difference between the two is between -1 and +1, if the absolute value is 0 or 1, then in that case we know we're close enough in terms of rows. We need to do the same thing for columns. So what we can do here is we can say int row difference equals this dot row minus other dot row. Get rid of this. I don't need that. But so math dot absolute value, which if it was -1, it'll be +1. So this tells us just how far apart they are, regardless of which one was above the other. And we'll do the same thing here. So, and then we'll do so let's see. If row difference is less than or equal to 1, and column difference is less than or equal to 1, return true, return false. So we could, yeah, so we actually could simplify that to just say return that. That's the same code. It's a little harder to wrap your mind around how that works, but we return whether the row difference is less than or equal to 1 and the column difference is less than or equal to 1. All right, so now we've got this method that'll tell us if two things are adjacent. So if monster is a maelstrom and monster dot location that is adjacent to player dot location is maelstrom nearby is true. I don't need these parentheses, curly braces. Get rid of them. So we're going to go through all of our monsters and we're going to see if they're a Maelstrom, and if they are, we're going to look and see if if the monster's location is adjacent to the player's location, and if so, then we know we've found one. And if we get through the whole loop and we'll complete the loop, and either we will have found one that's adjacent, a Maelstrom that's adjacent to the player, or not. And now in this case, if now this is a little bit like this. So if is Maelstrom nearby, then we change the color. What should we do for a Maelstrom? Say that's yellow. And what is the message we're supposed to say? We're supposed to say, you hear the growling and groaning of a Maelstrom nearby. Okay. So that should allow us to sense this guy. And the only thing left to do is to handle the situation where we actually run into one. And we had kind of come up with this plan. So we could have this code here. This is the game loop. So we run this, and then right here we could say, if the player is on top of a Maelstrom, then do something. Then move them. But what we can do is we could say, what we tentatively came up with is that we were going to have monsters have the ability to interact with a player. So we could just we'll make this abstract, public abstract, void, interact with player. But I feel like, oops, what did I just do? I feel like this needs, I feel like we need the whole game in order to allow monsters to have full range of what it means to interact with it. Because if we have access to the game, if we have access to interacting, if we have access to the whole game, then our options are pretty wide open in terms of what we can do. So now in here, so with that abstract method, this guy derives from it, so we know we are going to need to implement this. And in this case, so this method's only gonna get called if we're in the same room as the player. So what we said was game.player.location. So and I don't need to make a variable just for that. We're okay. Well, yeah. So we're going to get the player's location, and then what we're going to do is we're going to say, so how did this describe it? It said the player moves 1 space north and 2 spaces east. And didn't we already have code? I think it was in here. It was this. This is basically, well, this is basically what we want, except that we know it's not just based on a direction. I was wondering if there was code that would be really easy to reuse there, and I don't know that there is. What I'm going to do is just make a new location from the old one. So this says move north 1 space north. So row -1 and player location dot column 2 spaces to the east, so +2. And but what I need to do is ensure that we stay on the map somehow, because this could potentially, depending on where we encounter it, could shift to who knows where. So what, like for example, one thing we could do is we could say, now if player location dot row is less than 0, player location dot row plus equals, I was going to say 4, but game dot map dot rows. Yeah, it's not, it's a record, and by default those don't have settable properties, so we could make this settable. But I actually think I think that really what we want to do is actually, so that like there's going down this pathway could work, and we could say, I don't know, there's a lot of ways we could get this, but I think the simplest way that I can think of right now is to just do, I'm gonna yeah, I have a trick that I have used 1,000 times that I want to just use, but it would require some explaining. I'm just gonna add, like I can add in, I'm not gonna worry about it. We'll keep going down this path that we were looking at. I'm gonna make a new location. So if player dot location, yeah, if new location dot row is less than 0, new location dot row plus equals game dot map rows. Let me take a step back here. Let me take a step back here. What we want to do is, if the we're gonna create a new location that is, well, I'm exploring a whole bunch of different ideas in my mind of how we could handle this without writing 10,000 lines of code. What I want to do is say, given that the location, like one thing we could do is we could just say, let's just make this settable. Public int row get set. Same thing with column. So we don't, like, at this point we've lost a fair bit of the benefits of a record, because it's no longer immutable, and like it's got some logic. I mean, yeah, it's got some logic to it. Like maybe this could have been a class at this point. Who knows? But so we could, now that makes this code easier. If new location dot row is less than 0, new location dot row plus equals, in order to wrap around, we want to just add in game dot map dot rows. If new location dot row is greater than or equal to game dot map dot rows, new location dot row minus equals however many. The one thing I will say here is there would have been a way to do this without making that. Like we could have just made a new location instead of making that mutable. But get them all. I think I got them all. So the player shifts up a row and then to the right 2 rows. We actually need to do the same thing with the Maelstroms location. So my own location dot row equals, well, and we need to actually say there. We actually need to move the player location dot column plus let's see, we want a minus equals 2 and location dot row plus equals 1. You know, we could do the same thing here, but anyway. And now we got all this exact same code, just different. So I will say I don't like that. I don't like how that works where we've like duplicated all that code, and it would be really easy to just come in here and just say private. Let's see, private location wrap around. Just make a method here that just does that code, does that thing here. Let's take this and just say this. So I'm going to go out of my way here to not affect the original. Except for that, what I just did there will. This will be the same reference. New location. Okay. So we'll make a copy of that location. And then we will check all 4 directions. And then whatever we end up with is what we'll return here. So new location. Now we can just say now we just call that method, passing the location in the game. And then down here we can do a similar thing. We can just say location equals wrap around new location my location dot row plus 1, my location dot column minus 2. It's in the game. Don't need any of that. This version ended up a lot more condensed than this version, but in theory, we actually ought to be able to do literally the same thing. We could just say game.player.location equals wrap around. Oh, I've got that a little bit wrong. Well, for one, I need to pass in the game. But 2, this should be game.player.location. Should be that. Though, I mean, that's a lot of redundancy. And maybe we should keep that simple and just do it like that. Okay, I mean, I think that'll do it. I think that'll accomplish what we're looking for. It actually means we're done. Let's test it a little bit and see. I'm going to bring this up too so we can look at this while we are at it. Let's just start with a small game. So we're at 0, 0, move south, move south, move south, move east. So at this point, we should be able to feel the, yeah. Oh, yeah. The yellow. Oh, they're both yellow. Maybe we want to change the color of that text. It's just dumb that this is yellow and this is yellow. So, I mean, it sounds like we found it. So we move into it, move east. So the player, we should move up 1 and to the right 2. So basically, right this second, we're right here. And if we move east, we're going to be right here, which will move us up to here and then over 1. And we should wrap around to here. It should land us here. This guy is going to move down 1, which is here, and over 2 to here, which is the entrance space. Let's see what happens. Move east. Doesn't look like anything happened. I know why. It's because we never wired that up. All right. So we did the work in here to I'm gonna stop this, but we did the work in here to interact with the player, but that's never called anywhere. So in the run method, what we want to do is this: for each monster in monsters, if monster dot location equals player dot location. By the way, that is only working because we get a because this location class is a record. Because of how records work, equality is defined with value semantics. So row and column here, like it'll check all of the properties. So row and column in this case, it'll go through and check all of those, and so if they share the same row and column, it'll work. If this were a class, we could, if it were just a plain old class, there is an option, we haven't learned about it yet, where we can define how many of the operators should work, including the equals equals operator, the double equals operator, the equality operator. So we could, like, if this were just a plain old class, we could go define that. Or maybe we would need to do something else to handle it. But because this is a record, equality for this type is defined already when we use this equals, double equals. it's going to check the row and the column and look to see if they're both equal. So if the monster and if the monster's location and the player's location are the same, then we'll say monster dot interact with player. I'm missing something important. This, not game. I'm in that class. So this code here will allow monsters in the same room to interact with the player. Now let's try that again. So small, let me bring up that map again so I can track it. This guy started here. Move east, move east, naval fountain, move south, move south. So now I'm right here. I already turned on the fountain. So now I'm going to move into the maelstrom, move south. So now this guy, I'll move me down to here and he'll go one, up one, then over two to here, wrapping around, and he'll go down one and this way too. So he'll end up at the entrance. Now this is working in general. Like we're at row 2, column 0. I think if I move north, yeah, so Maelstrom is in our way now. So yeah, it would have been better for it to have told us that we got swept up by a Maelstrom and got moved. So we can add that in, and I'm remembering now with the color we want to change the color. But so there's no way around this but moving into that room, and that's going to cause us to shift again. So right the second I'm here, and it's going to move us up to here. So this is going to move me up 1 and over 2. So I'll put me here, and it'll move him down 1 and over 2 to here. Move north. So I'm now at row 3, column 2. Row 3, column. Yep, that's right. And I can move north. And if I move north again, I'd be into that maelstrom again. So let's not do that. Let's go around it. Move east. Move north. Move north. So now I'm up here in this top corner, and I just got to move west. Did it. Okay. So I think it's working. And like I said, at this point now, it'd be really easy to come in and add in a new monster type that has a different interaction with the human. We are, like, the way we've built this, we have some flexibility because any monster has the ability to interact with the player in any sort of way imaginable. But yeah, I mean, yeah. So it's given us a bit of flexibility here. There's other monster types we could add in, but all right. Anyway, there were a couple of things we wanted to change. One of them was this. We wanted to do something like console right. You've been swept away in a maelstrom. You and the maelstrom have moved. But I actually want to do console dot set the foreground color to something. Let's just do red. And then I wanted to sensing to change this color to dark red. I think that might have been it. Let's try a medium game. Bring up the map here really quick. So now we're here and we're starting here. Move south. Move south. So if we move west, we'll be. I'll put my token. So I'm sitting right here now. If I move west, I'll be here, and it'll move me to here. And I'll move this guy to here. And now it actually tells us that we moved. And it tells us there's a pit, which is right. I think it sounds like. Now we're detecting that the maelstrom down there again. Okay. So I think that covers it for this challenge. I think let's double check really quick, but so we got it added in for our different sizes. If we enter a room with a maelstrom, then we move and it moves to ensure we stay on the map. We did handle all that. The player can sense maelstroms by hearing them in adjacent rooms. We did handle that. Okay, yeah, I think we've got it. Are there any design anything we want to clean up? Anything that we don't like? I mean, like I said, we did in some ways we've made this a little bit more complicated by having kind of building in some infrastructure in case we want to add in other monster types. And if we were done here, like if we were going to stop, then I would say we've over designed it. We don't. There's no need to add in extra classes, extra methods, extra stuff if it's never going to get used. But in this case, it seems okay. Seems reasonable to have done it this way. I do think there is another challenge, that the Amarok challenge that we'll do next, that is another monster type, and so I think it'll make that one easy. We'll have to see. That's a guess. I think it will make it easy, but I don't know if it'll make it easy. So I guess we'll find out in next time. But I think that's it for this challenge. We've accomplished everything here, and it's time to be done. So thanks for joining me, and I will see you next time.